Hello, and welcome to the Green Building Research Institute's residential series, The Elements of a Green Home. Many philosophies around the world believe in a classical set of elements that are believed to form the simplest essential parts that make up everything on Earth. The most widely held theory of classical elements is that there are four: earth, water, fire, and air. Some cultures include a fifth element called space, idea, spirit, or void. We define an additional sixth element as the built environment, the combination of all other elements into a man-made structure. In this series, we would like to talk to you about how these six elements play a part in sustaining your home. We've organized this 6-hour course into 3 2-hour courses that represent the elements: sites and energy, representing the elements of earth and fire; water and materials, representing water and the built environment; and IEQ and innovation, representing air and idea. We hope that you will find all of these sessions informative and come away with some great ideas for greening your residential projects. Today is our first session, where we will be focusing on water and materials. This course will include discussions related to the importance of green homes and the current drivers promoting design and construction of green homes in North America. We will discuss strategies related to water efficiency and material selection that can be applied to the design, construction, and management of a home. We will link each of the strategies discussed to applicable LEED credits available under the LEED for Homes rating system. A LEED case study will be discussed to analyze the execution of the strategies we discuss. A green home is one that is designed to be environmentally friendly and sustainable. Green homes focus on the efficient use of energy, water, and building materials, and on doing no harm to their local and global environments. Green buildings and homes are often certified by third-party rating systems, and each system uses its own criteria. Some examples of green home certification bodies include LEED for Homes and the National Association of Home Builders National Green Home Certification. Owners of green homes not only save energy and reduce their environmental footprint, but can also realize many other benefits. Green homes generally have lower operating costs from energy and water bills as a result of improved efficiency measures. As green home building has become more mainstream, there are more federal tax credits and local government and utility company incentive rebates available, providing financial incentives for building a green home. Green homes are also healthier for occupants because of improved indoor air quality, less harmful off-gases, and prevention of water intrusion, which can create mold. If your green home is certified, it will often have a higher value than a comparable standard home, and it's much easier to market the benefits of the home to buyers. Green homeowners are also generally seen as more involved in the upkeep of their home, and having made green improvements will show potential buyers that the home has been well maintained. A green home will have less maintenance and repairs because of the increased useful life of sustainable products and materials, and this will in turn result in cost savings. For example, a properly planned landscaping system will reduce the amount of time spent maintaining the yard, minimize the water consumed, and reduce the need to replant as often. As you can see from this slide, there are many benefits to building green. In the United States, there are various codes that prescribe how homes are built. There are many reasons why building codes exist, but primarily they specify the minimum acceptable level of safety for the built environment. Building codes protect public health, safety, and the general welfare of the citizens that occupy these structures. However, building codes fail to adequately address sustainability and the relationship of the built and natural environments. A code-built home meets the minimum requirements as set forth by the government, whether state or local. When builders exceed code, they often see a dramatic increase in energy savings and will typically notice a drop in carbon production, water use, and waste production as well. This graphic shows the water savings you can get from replacing different older toilet models with water-efficient low-flow toilets. If toilet flushing accounts for 26.7% of your indoor water use, and you replace a 7-gallon toilet with an efficient one, this will work out to a 20% total reduction in your indoor water use, which can be pretty significant. As our population grows, our cities expand, and the amount of waste we produce balloons, managing waste is becoming a greater challenge. Luckily, there are several alternatives to the less eco-friendly methods of landfill and incineration. Reducing the amount of trash we produce, extending the lifespan of products, reusing materials, and recycling our waste into new products are all key components of modern waste reduction and play a critical role in the reduce, reuse, and recycle waste management triad. More and more cities are offering recycling programs, and some offer curbside pickup and sorting. Typically, these systems accept glass, paper, plastic, aluminum, and cardboard. Recycled products can often have the added benefit of reducing air pollution from the incineration of garbage waste, reducing water pollution from landfills, and reducing the costs and impact of conventional waste disposal. For LEED for Homes, construction waste management is covered under MR Credit 3, Waste Management. This credit does include a prerequisite for which you must investigate and document local options for waste diversion from the home and document the diversion rate for the construction waste. Once this is done, projects can earn up to 3 points for construction waste diversion through either reducing waste to less than 2.5 pounds per square feet or by diverting 25% or more of total project materials away from landfills and incinerators. We will return to Eaton Street for our materials case study and look at how the project made good use of materials and practices. The project earned 9 of 16 possible points in the Materials and Resources section for LEED for Homes. Best practices begin in the early stages of design and construction. The aggregate for the foundation was locally produced, and the building pad was made from reclaimed material from a local road project. The concrete for the foundation contains 30% fly ash, which is a pre-consumer recycled material. For the building's framing, wall, roof, ceiling, and floor components were fabricated off-site, which prevented enough waste to eliminate the need for a 140-yard dumpster on the construction area. The studs used were made from recycled wood from local lumber mills.